Okay, in this video, I'm going to show you how to work an inclined plane problem. So again, the equations are the same as what you've seen before, except for now we're looking at that height of the inclined plane is going to be our distance of our resistance, and the length of the slope, the actual length of that I guess the ramp part would be your distance of your effort. Okay, so Caitlin pushes a 500 Newton box. All right, the box is the inanimate object. All right, it's the thing being pushed. So we know that our force of our resistance is that box being pushed, so it's 500 newtons. All right, up an inclined plane that is 4 meters long and 1.2 meters high. All right, so if we know the height is always your distance of your resistance is always going to be that height. So it's 1.2 meters high. And then that means then that the other would be the distance of the effort would be 4 meters long. So what force does Caitlin apply to push the box up the ramp? All right, so our force effort equals what we're trying to find out. Now, if you're in my class, you know that I've been calling this Hogantopia, that when we look at something like this, we have to assume ideal. And of course, my ideal world is Hogantopia. And we have to assume that there are no outside forces that are going to act upon it. We're assuming that IMA equals AMA. In the real world, that doesn't happen. But in my world, we're going to say it does. So I'm going to set it as force resistance over force effort equals distance effort over distance of resistance. So if I plug it in and cross multiply, then I have 500 newtons over x equals 4 meters over 1.2 meters. My meters cancel out, leaving me with newtons. And I'm just going to cross multiply these. Multiply these two together first and divide it by the one with the x. So let's go ahead and multiply that out. 500 times 1.2 divided by 4. So it's 150. Okay, so it's 150 newtons. So what is the next part of the problem? This is what is the work input? Right, so that means if our effort is considered in, right, that would be input. So I'm going to say that work in equals force in times distance in, which again is the same thing as effort. So that means it's 150 newtons times distance of my effort is 4 meters. That equals 150 times 4 equals 600 newtons. That is how much work was put in. All right, so the next part of the problem says, what is the IMA of the ramp? And what does that number mean? So IMA equation, kind of move it a little bit so we can see it. IMA equals distance effort over distance resistance. So that equals distance effort is 4 meters over distance resistance, which is 1.2 meters. So 4 divided by 1.2 is 3.33. Again, meters cancels out, so I have no unit. So IMA is 3.33. That means it is 3 1/3 times easier to push that box up, again, assuming no friction, must be on rollers and again in Hogantopia. So that's what that means. It's easier. It's 3.33 times easier to get that box to that same point by pushing it up a ramp than it is to lift it. Okay, now it says, what is the AMA of the ramp if Caitlin actually pushes the box up with a force of 250 newtons? Okay, so as you can tell, 250 newtons is going to be a lot more than what we expected. So now we're actually figuring in that friction. We're figuring in that outside forces. We are in the real world now. What actually happens? Well, our AMA equals force resistance over force effort. Okay, force resistance is 500 newtons, and force effort is 250, which we find right here in the equation, or in the word problem, 250 newtons. My newtons cancel out, giving me 2. So the AMA, what actually happened with the actual mechanical advantage, is going to be 2. All right, but it still made it 2 times easier. All right, so what does that mean? Okay, well, friction figured in. That's why it's smaller. And it's still 2 times easier, though, to push it up than just lifting it. So it still makes sense to do it. So what is the efficiency of the ramp? And what does that mean? So my efficiency, let's move this on up. All right, AMA over IMA times 100. So AMA was 2 divided by IMA, 3.33, times 100 equals, okay, so 2 divided by 3.33 times 100 gives me 60%. All right, so we've lost a lot to outside forces, right? 40%. So 60% efficiency. All right, and I'll be doing this next problem in another video. So if you still need a little bit of help, watch the next video.